Okay, this is question 13 of the WJEC Additional Maths 2015 paper. And this is about finding an equation of a tangent to a curve. And they tell you the point of contact with the tangent and the curve. And we've got to give our answer in the form ax plus by plus c equals 0. Because the tangent is a straight line, and that is the one way of writing the equation of a straight line. So the first thing we need to remember is the equation of the tangent, the gradient of the tangent is the same as the gradient of the curve at the point of contact. So what we need to do first is find the gradient of this curve at the point of contact with the tangent. So if I just draw a little sketch on the side, so if we have the curve here, if the tangent is touching there, so here's my tangent, then the gradient at that point of the tangent is the same as the gradient of the curve. Now to find the gradient of the curve, we use dy by dx, because that basically stands for difference in y's over difference in x. The differential then of 2x squared is 4x, and of minus 8x is minus 8. So this is a little formula for working out the gradient anywhere on the curve 2x squared minus 8x. All we need is an x coordinate, and yes, in the question we have got the x coordinate there, x equal to 3. So we put x equal to 3 in, and we have 12 minus 8 is 4. So the gradient of the tangent is 4, because it is the same as the gradient of the curve at that point where it is in contact, when x is equal to 3. Now what we're going to use to get the equation of the tangent is y equals mx plus c. That's our standard general equation of a straight line. We found m, okay, so this equals m. So we can write that in. Now all we've got to find now is c. Now to do that though, we need a point. We need the x coordinate and y coordinate where that lies on the straight line. Well, we know that one x coordinate, x equal to 3, is on that straight line, and if I substitute in x equal to 3 into my equation of the curve, the y coordinate I get out will correspond with the x coordinate, and that point, that x and y, will be a point that lies on my tangent, because that point is common to the tangent and the curve. It's on the tangent and it's on the curve. So we take y equals 2x squared minus 8x, and we take x equal to 3. We substitute that in. Like so. 3 cubed is 27, times 2 is 54, minus 8 times 3 is minus 24, so y is equal to 30. So at the point where the tangent is touching the curve, the coordinates are 3, 30. Now I know that point lies on the tangent because it's on the tangent and it's on the curve. So I substitute that point into my y equals 4x plus c, and I can work out the y-intercept, my c value. So instead of y, I'm going to write 30. Instead of x, I'm going to write 3. I've got plus c, and I can work out c. And this is typical of normal GCSE. When you're finding the equation of a straight line, you've got to find m, you've got to find c. So you've got to be able to work out the gradient, and then you need a point on the line to work out the y-intercept. Take away 12 from both sides, we get 18 equals c. So the equation of the tangent now is y equals 4x plus 18 instead of mx plus c. 4x plus 18. But they want it in the question ax plus by plus c equals 0. They want it in that form. So I need to rearrange this until it looks like that. All I need to do really is subtract y from both sides. This is going to be the quickest, and then swap it round. So if I take y away from that side and take y from that side, I'm going to get 0 equals minus y. Sorry, I'm just going to rub that out. I'm going to write the x first. It should be alphabetical. I'm going to write 4x minus y plus 18. And then, just so it looks exactly like they got in the question, I'm going to swap that around and write 4x minus y plus 18 equals 0. And there is the equation of the tangent in the form that was requested in the question. Thank you very much.